Okay. That's fine. I just wanted to go to the second video before we moved on.
So for C, should I use 13.75 or should I?
I just use 13.75. It's fine.
Alright, so we know that 27.5 times dc dt equals 360 sine theta, which is going to be sine 60 here, which is root 3 over 2,
Okay.
times d theta dt,
Yeah, times d theta dt.
which is plus 2 degrees per minute.
Yeah, this is the tricky thing we've not talked about before. So when you do trigonometry in calculus, everything's got to be in radians.
Okay.
So you gotta switch 2 degrees a minute into radians.
So it's 2 times pi over 180. I think that's how you switch.
Okay.
Yeah, so it's pi over 90.
There you go. So that's something we haven't talked about yet, but that's fine.
So pi over 90.
Mm-hmm.
Which is going to okay, this is just messy algebra now.
Yeah.
dc dt is 360 times root 3 times pi over 2 times 90 times 27.5.
2 times 90 times 27.5.
Yeah.
So let's call it, actually it's about 0.2. Okay. All right, now there's no real way to have much intuition about this, right?
Yeah.
So how would you want to see, like, even if this made sense? This is probably a good way to check, because actually I think this is an even number problem, so we don't have an answer in the back of the book. Yeah, it's problem 24.
Well, it's not increasing by a lot.
Okay, it's not increasing by a lot.
Which is to be expected, since we're not near 180.
Uh-huh.
And C is fairly big. If C was like 2 and it was increasing by 0.2, that would seem not very good.
Okay, but what's a calculation we could do to check and see?
We could set theta equal to 61 or something.
Okay, when will theta be 61? How much time later?
Half a minute.
Half a minute later. So if this is right for approximately how many meters per minute it's changing, and we plug in 61, what should we get as the change?
About 0.1.
About 0.1. So let's go ahead and do that.